Hi, my name is Mark, and I'm going to show you how to design a yo-yo in FreeCAD. I'm currently using FreeCAD version 0.19, which I downloaded off of GitHub with the FC info and the glass add-ons installed from the add-on manager. FC info is a macro, and glass is a workbench add-on which changes the look of FreeCAD somewhat. So let me go ahead and close this example one and start a new project. And I'll walk you through what you need to do. All right, so in FreeCAD, uh, there's a drop down up here with a list of all the workbenches available to use. You're going to want to start in part design. And in the task tab, you can just click on create body, create sketch, choose the XY plane. You can click here or there, and that'll drop you into sketch mode. I'm going to change this grid to 5 mm so it's a bit closer together. 10 mm is not really useful for yo-yos. So now it's automatically dropped us into the Sketcher workbench. It'll switch you between Sketcher and part design depending on what you're doing with these parts. And you'll see that the sketch is inside the body. There's also origin right there. If you select something and hit space, it'll hide or show it. Anyways, we're in the sketch. So how does CAD work? How does FreeCAD work? What you're going to end up doing is create a drawing. Let me just create a square here. All right, that will not be a very good yo-yo, but it'll be a good example. An actual yo-yo drawing will look something like this. You can see the guts down here. The cup is on this part on the left. The rim is up here on top. We're going to end up somewhere around there. And then this red plus is the very center of the yo-yo. Anyways, let's go ahead and close this. Here's an example sketch, and then to turn that into a yo-yo, you hit this revolve. We're going to use the horizontal sketch axis, and there we go. Our very first yo-yo that's shaped like a donut. That's great. And it's not very good either. FC Info is reporting that this would weigh 97 grams in 6061 aluminum. All right, so we can go back into the sketch and fix it up to make it a bit better for a yo-yo. So there's kind of the two ways to approach this. You can start building up the guts, or you can work on the general shape of the yo-yo first. I'm going to start with a general shape using the polyline tool, which will allow us to just click and create a whole bunch of points. I do have auto constraints turned on, which will snap them to horizontal or vertical as needed, or onto the axis there. So I'm just going to completely gloss over the guts for a moment. We'll come back and do that properly later. I'm just going to connect this up. I hit escape to turn off the tool. And now I'm going to add some constraints to some of these so that they line up. Right now it's a little crooked. H makes it horizontal. V makes it vertical. I'm just going to do that real quick on those two pieces. This line is already stuck on the axis. That's fine. This one we want to be horizontal. And then this is going to be the like tip of our yo-yo. It's really pointy right now, but that's fine. We'll fix that later. I'm going to go ahead and I'm going to select that point and this. You don't have to hold down anything to select multiple things. It'll just let you pick more. If you click somewhere else, it'll deselect everything. So I'm going to click the vertical axis and this point right on the tip, and hit the length, the horizontal length constraint, this will be the width of the yo-yo. Let's say we want to be 44 wide. The distance for half of the yo-yo would be 44 divided by 2. You can just type that math in there. Millimeters. I'm going to move this up to the top. There we go. I'm also going to create a vertical constraint on that. Let's say 55 divided by 2 for the radius. There we go. So that's kind of the outer bounds of the yo-yo. That's the upper left-hand tip of our sketch. Very good. So we know that we want our stuff to kind of like fit into that space. All right. And to kind of get a sense for how big the guts need to be, this point is going to be as tall as the response pad. So 19 millimeter pads divided by 2 to get a radius would be 9.5 millimeters there. And then this is also going to be the gap width. So let's say 4.5 divided by 2. There at 2.25 for half of the gap. And then the rest of this guts is just going to fit into there. And we'll refine that later. So let's just put this around here. All right, let's see how this is looking. It certainly looks more like a yo-yo than before, and FC Info is reporting that it weighs 35 grams. If you double that and add a couple grams, we're looking at like a 73 gram yo-yo. So we can go in and start refining this design to be something closer to what we would actually want in a yo-yo. One of the most important things actually is this edge right here is super duper sharp. I'm going to add a fillet to that. Notice that those constraints were deleted. This is because that point that they were constraining is no longer there. I'm going to make this edge 1.4 millimeters. There we go. And I'm also going to add a fillet to this. And I'm going to press Shift R to add this constraint. Let's do 3 millimeters. And we can drag this point around to set where it is. The wall coming off of here, I'm going to add a response bump. And I'm going to use the trim tool here to get rid of that piece. Add a fillet here and here. I'm going to set the radius of this fillet to 1. And actually, I'm going to have this arc connect directly to the other one. I'm going to select those 2 points and hit C to make them coincident, and then select both arcs and hit T to force them to be tangent. So those 2 arcs are now tangent to each other, which will cause a sort of like smooth connection between them. I'm going to set the radius of this to 3, and for the wall height, Shift D. I'm going to make that 0.6. All right, so now that part of the wall, the response bump, is kind of like locked in place. All right, so I guess this is going to end up like sort of an H-shaped yo-yo. I want these 2 lines to be parallel, so I'm going to hit the parallel constraint, which is Shift P. And I want to set a distance between them. Let me fillet these 2 sections so that I'm adding a constraint to a point that is not going to get deleted later. So that point in this line, Shift D for 6061, maybe like 1.5, 1.6 millimeters seems fine. And now these 2 lines are going to be a constant distance from each other, and they're always going to be parallel, which is fun. I'm going to add a radius to this, 2, 2, there we go. Add a fillet here. That's a very tiny one. All right, this is going to be an H-shaped yo, so I'm going to make this vertical. Oops, just regular V, not Shift V. Make this smaller. There we go. And let me add a radius. I'm not sure what I want to do with this part of the yo-yo yet. I'll just add a radius on this corner right now, so it doesn't look pointy when I drop back out and look at the revolve of the yo-yo. This is a pretty weird looking shape right now. I just hit escape twice and it closed out the sketch. Here it is. That's something. That's 33 grams. It's lighter. It's looking all right. The guts need a lot of work, so I think that's the next good thing to work on. Let's go in there and fix it up. So we need the bottom of the response mode, so I'm going to add that, and we need the little shelf that the bearing sits on off of the post. Let's make that horizontal, and I'm going to use the trim tool to cut that and this and this. All right, notice that it left a constraint between these two lines, caused them to be tangent, so those are always going to be the same depth. All right, and then there's going to be a hole in here where a machine shop will drill out an axle hole. Let's trim this, trim that. If you look up how big of a hole gets drilled for an M4 axle, recommended tapping drill size. You can find a lot of this information really easily. So M4.7, the drill will be 3.3 millimeters in diameter, and we are using a radius, so we're just going to use half that. Let me go ahead and just set a 3.3 divided by 2, 1.65. There we go. That's how big the hole needs to be. Let me add a fillet on the end of the bearing post so it's easier to put the bearing on. 0.5, there we go, nice and rounded. And let's make the bearing post about 1.2 millimeters long. It's not too long, that way it'll be easy to add and remove the bearing. Right now, the thickness of it is not constrained. So I'm going to pick this corner point and set a, oops, an origin. Shift V. It's a 1/4 inch diameter for a C bearing, so 1/8 inch in radius. I'll put us there, 3.175 millimeters. This little shelf, I've measured it to be about 0.7, 0.8 on actual yo-yos, which seems fine. The inner race of the bearing will rest against that, and then there's this air gap so that the rest of it's not like getting bothered, not rubbing against it or anything. All right, so the width of the bearing is going to be between these 2 points, Shift H, and it is half of it is 3/32 of an inch. The C bearing is 3/16 of an inch across, and this is half of it because this is only half of the yo-yo. So 2.38125 millimeters. Your bearings may be different. All right, I'm going to add a a fillet on this part of the pad as well. I need to add the pad constraint again. I'm going to make this 0.1 millimeters radius. I'm going to add fillets to these as well because the string will rub against them. I'm going to take these 3 radii and make them equal. There's an equals constraint, or E. All right. It's looking closer. Still need to add a few constraints so it's actually like accurate to a real size here. So this piece needs to be constrained, and the depth of these needs to be constrained, and I need to add the pad size again. So here is the pad diameter, 19 divided by 2. I accidentally set the width, the horizontal instead of vertical constraint. Let's try that again. Shift V, 19 divided by 2. All right, good. The inside is going to be like 14.2 in diameter, so that'll be 7.1 radius. Very good. And this little piece here is going to, it needs to be just high enough so that the bearing can't touch it. Let's go back and add a pad depth again. 1.15. There we go. And let's add our gap width again. H 2.25 is what we're using. There we go. And this, we want that to be like 0.5 millimeters. All right. So those are all constrained again, which is good. That's what we like to see. Gap width here, that one's important. That one's important. All right. I'm gonna make this and this line tangent. So now the height of this is, or the distance that this is away from the bottom of the pad mount is now fixed. Those are in line with each other now. All right, so let's set the height of this. We're going to use some construction geometry. So I'm actually going to make a line showing where the bearing will end up being. So let me do 1/4 inch is the radius of the outside of the C bearing. So we want this to not touch the bearing, right? I'm going to make these line up vertically. All right. And this is like the edge of the bearing. If the bearing was perfectly squared off on the corner, basically we want just enough distance here. So let's create a vertical distance, 0.1 millimeters. Although I've heard if you send a CAD file to a machine shop where those would actually touch, most of the reputable yo-yo shops will fix that for you because they do not want to send you a yo-yo where the bearing is constantly grinding against parts of the yo-yo body. But you might as well add that clearance yourself just in case. It's 0.1 millimeters. I recommend getting a set of calipers and actually you can measure some of these different parts that aren't typically like announced or whatever. All right, this needs to be horizontal. H. How deep does this hole need to be? Let me set an angle between these. 115. It depends what kind of drill they're using. I just want it to not to look at least like something resembling how it would actually look like. All right, I set a horizontal distance here. 5.2 would give it enough room for a 10 millimeter axle. Just remember, this is half of the yo-yo. And then between the bottom of this and the face, you're going to need enough space. Let's just set this to 6.5. All right, that'll give it a bunch of extra material in here. So you can see that when you have a flat cupped yo-yo, there's a lot of extra material in here, especially with a longer axle. If you were to use a, and if I don't think there's a line there anymore. Huh. All right, let me add that line back. Click, click, and horizontal. All right, let's set a distance for this, 0.8. Okay. So if you use a shorter axle, 4.2 for an 8 millimeter axle, you can see a lot of that material just gets removed, which is good if you don't want a lot of center weight on your yo-yo. All right. Let's pop out and see how this is looking. The guts are sure a thing, and it's 32 grams. It's a bit lighter now. That's good. Let's go ahead and save this. Call this H shape. Let's go ahead and add a mirror image of this in the part workbench. So select body, change the drop down to part, and then I'm going to hit the mirror button. And because the sketch is on the XY plane, we're going to mirror across the YZ plane. Hit OK. And this is what it would look like. Let's do orthographic. Look at the front. Here's the profile of the yo-yo. That's pretty cool. Even after doing this mirror, you can still go in and edit the sketch, which is great. Let's bring this up a bit. Get rid of some of the weight. Let's make this 5.2, and we can give it a hub design that's a bit more efficient. Let's give that a bigger radius here so that this angle doesn't get too shallow. Let's fix that first. That's very important. All right. So what we're going to do is delete that flat hub and give it a hub of a different shape. So I'm going to bring that close, basically carving out all of that material, and we're going to add an arc here. This is a classic way of making a more efficient hub. You have like a dome or some other shape. All right, I'm going to make these two lines tangent. That way this hub will look smooth right in the middle. These are going to be tangent with T. And this point, we just don't want it to be too close to there. Let me change this grid size to 1 so I can just kind of like eyeball the distance. We could add a constraint, but eyeballing it for this is probably fine for now. All right, this is the thickness of the main body. Let's see. All right, let's close and see how that looks. It now weighs only 31 grams per half, which is good. We lost a lot of center weight. The hub's looking good. Let me turn off the lines. This is a very aggressively H-shaped yo-yo. Very cool. And we can see FC Info is reporting a moment of inertia there. I would personally like that to be a little bit higher. And we can refine the sketch a little bit to make that happen. You just make the rims broader and pull away some of this weight that's not contributing as much. Here we go. That's a lot of changes, so we'll see where the mass is turning out to be. There we go. We're over 15K per half, which is a nice amount, I think. That looks pretty good. Maybe. Yeah, it's pretty good for 25 minutes work. And if you're at a machine shop with a lighter 6061, that's like 2.7 grams per centimeters cubed, you can type that in. There's other alloys as well that have different densities that you can see. All right, there you go. There's our H-shaped yo-yo. How do you export this so you can send it to machine shop? Well, one way is you can go to the sketch and hit File, Export, or Control E, and save it as a DXF file. All right, hit OK on that dialog, and open that in FreeCAD so I can see it in like a much better DXF viewer. There we go. That is our Yoyo Design file for the H. Thank you for watching.